Hello everybody! This is lesson 3 of your sequence of lessons all about cost of energy and energy and electricity. I apologise, the videos do seem to have this weird little bug at the beginning where it doesn't seem to export the PowerPoint properly, so hopefully that won't happen this time, and you will hear all of this. I've said that the last video as well, and then it skipped it. It's almost as if PowerPoint and they're conspiring against me, criticising them. I don't know. We'll see. So let's go through this nice and easily. If you are working offline, then you won't be hearing this. But this whole thing is that you can either watch this video on YouTube and follow it through, pause it when you need to, etc., or listen to my little sound bites in the corner of the PowerPoint slide, or just follow the instructions that are in front of you. So, copy the title National Grid, have a think about the start question, which one's odd, why, all those different little things, okay? So it's all there for you, is what I'm trying to say. You should be able to access in lots of different ones. So let's get into the starter. Your starter is electricity generation methods. Which one is the odd one out and why? I suggest you pause here and have a think about it. Think about which one is the odd one out and why. Right, so I hope you had a good think, and what's always a good thing is when I ask you this is the why, the justification. What is it that justifies your answer about this? So all of these are methods of generating electricity, and yet there is an odd one out, and hopefully you picked the top left hand corner, which is the wind farms and the solar panels right next to each other. They are the odd one out, and do you know why? Well, hopefully you said there because they are renewable, and all the other ones have some form of they're using a non-renewable source because they're burning something. We could argue, obviously, things like trees are now sort of classed as renewable / kind of carbon neutrally, but we are really they are non-renewable. Big giveaways are the cooling towers. When you burn something, you generate a lot of steam, and you'll cool the steam down and reuse the water that you heat up and boil to turn a turbine. We'll come back to all this later. The middle picture on the sort of top row is obviously an oil rig that is, pretty self-explanatory. It's taking out oil or gas from the ocean. So all those other ones, other than the top left one, all use a fossil fuel to generate electricity, or they're related to fossil fuel generation. The top left has got a wind farm and solar panels, which are renewable sources. Fantastic. Okay, so hopefully you know what a renewable source is and a non-renewable source is. If you're not sure, I'd have a quick look at what they mean. You don't need to worry about that for now, but maybe you're sort of having that question in your head and you're like, oh yeah, renewable, non-renewable. I think I did this at some point. Oh yeah, yeah. Go for it. Have a quick check on it. Right, let's go into the national grid. The national grid. So your title is the national grid, and your learning objectives are kind of as follows. We need to describe what the need for a national grid is, explain how each element of the grid helps with it, explain the need for step up, step down transformers, and complete some higher level questions on the national grid. So throughout this lesson, we're going to talk about the national grid, the components of it, and then I'm going to get you to sort of talk about why we have this and use of transformers and things like that. And then at the end there's some high level questions on here, and also there's on Show My Homework a quiz for you to do as well to see what you know. All right. Final thing, when you get in a little bit, which I'll explain in a minute, you'll have noticed that there's a slide at the end of this PowerPoint where there's pictures of parts of the national grid. Now, you can use those to do the task that you're going to see later, or you can cut out any pictures you want for the national grid, or just draw them as I'm going to ask you to do. So if you're in school, normally I'd ask you to draw it. Okay, first, what is the national grid? What do you think it is? Have a think about it, pause the video, have a think, maybe go and ask parents if they know. It's often very interesting to see what they know, and come back. Right, hopefully you have got some kind of answer, and maybe it is along the lines of: the national grid is a network of power stations and cabling that carries electricity around the country. And I hope your parents gave you that exact definition. I'm sure they didn't. I don't think I could have done at some point until I learned about this being national grid. I just could have. I think I remembered national grid being like a thing that, weren't they the ones that gave us our electricity? That's probably about as much as I remembered. Okay, so electricity is generated at power stations and distributed around the UK through a vast circuit of electrical cabling. So I suggest you copy in that definition of a national grid, and you can copy in the electricity generated sentence as well. I'll give you some time to do that. I'd suggest pause the video and then we will move on. Okay, so we've got to sort of describe now. Basically, it said what the national grid was, but we need to describe what it is actually. Our need for it. Why do we need a national grid? So, if the national grid is all a big thing about cabling and helping supply electricity, why do we need it? Why do we need these pylons all over the place? Why do we need these cables all over the place? I'll let you think about that. You have a think. Pause the video. Go away and think about it. Why do you think we need a grid, a national grid? Oh, and also, sorry, what could the alternatives be? What else what would you do if you didn't have a national grid? Okay, because not all countries do. Go for it. So, why do we need a national grid? Well, the big thing about a national grid is it allows the electricity that we generate to be transferred efficiently across the country. So, very interesting that happens. On the way our national grid is, because we've had some very clever scientists in our, in history, and Britain especially were quite big pioneers of doing this. We chose to use alternating current and transfer our electrical energy efficiently through wires that way. If you did it in lots of different ways, you'd need more power stations. Okay. So this allows us to transfer huge amounts of energy across a large distance. All right. Now, so it helps reduce the energy loss. That's a massive, massive thing. It's kind of like the big top tip about learning this is that having national grid helps reduce energy loss. It's really important. Also, takes up less space. So if you had, for example, let's say Staines, Chertsey, Addlestone, Weybridge, Walton. Try to think of it. You guys will probably tell me some other. You can sit there shouting other things, maybe Hersham, I guess. All those small little towns and villages all around you, and if they needed a power station just to power them, then yes, it might be great that they can get power directly. But if that power station failed, then all of those towns would go out of power, not just a small area. Okay, and two, it would take up lots of space. It would cost a lot of money to do so, and it would take up massive amounts of space. So we have a national grid to kind of reduce that. Is what the cables and the pylons are all about for. Okay. If there's a big problem in one area, more energy could be diverted. So yeah, so if a power station locally that supplied us did sort of collapse a little bit, if it will collapse, but if the power does go down, they could divert somewhere from like Norwich more electricity to us, power stations in that area, and even Wales and north of England and things like that. So alternatives, as I've just mentioned, you could put a power station in every region, but that wouldn't work. However, in places, especially in sort of hot countries, hot sandy deserty countries where, most places have got sort of big cities that are built up around the area, and then there's a lot of desert in between the next city, they often will have their own power station, and that's fine and quite efficient. I wonder if you know why, especially in some of a hot deserty country. It's because they have a lot of oil, so they can just basically ship their oil around and stick it into a power station, and they'll be happy. Also, they've got a lot of sunlight as well. Lots of these places are moving off to solar energy. All right, well done. So hopefully you can now explain what each element of the grid does. So national grids. Over the next few slides, I'm going to ask, sort of explain what's going on, ask questions about it, and what I want you to do is that diagram in front of you. I would suggest you copy it, turn it landscape, and copy a diagram in that way, or however you want to do it. You can, if you've got access to print this, print it out, stick the picture in, print the last slide as I mentioned. Do whatever you need to do to get this information in, okay? You can even, if you want to, draw a little picture of this and then bigger pictures of each part later to add all the notes to. So we're going to go through and explain each part. Now, the first part about the power station, there's going to be a few little bits to it. So if you've noticed, I've color-coded the words so just to show you they all match together. So power station's got a few slides that go with it, all right? And actually, we'll talk about electrical generation in a power station, like in a much more detail in another lesson. So, power stations. So, fossil fuels get burnt to heat water. So, you're literally just boiling. That steam that gets generated, just like it comes out at the end of your kettle, gets forced at high pressure into a turbine. You can see a turbine in front of you right there. All right, they're massive, they make massive amounts of noise, so there should be lots of energy loss, if you remember the lessons before. So if noise is another energy loss, I wonder what you could think of is one other than just noise. They are super noisy. I'll let you think on that. Well, heat from friction. There's going to be a lot of friction, so if they're trying to be as efficient as possible, they're going to want to reduce the amount of heat loss through friction there, so they'll have lots and lots of methods of doing that. So high pressure steam forced through the turbine, making it turn. Don't forget, obviously, pause at any point if I'm going a bit too quickly, okay? I'm trying to obviously not make this video too long for you. Right, so still in the power station we have a generator. So the turbine is attached to a generator and that is what generates your electricity. It's a bit like a motor, all right, but without obviously working independently of itself. This one is actually generates electricity. It causes electrons to move around using big magnets and things. We're going to cover into a lot more detail of that in another lesson, okay? So turbine attached to a generator which turns to generate electricity. Right. On the step-up transformer, so that's after the power station. So what happens is, in the UK, especially in other countries, is we have worked out that the higher the voltage, the lower the current that is in the wire. So what that effectively means is you can send electricity slower and there's more of the energy, but you send it slower, so there's less heat loss. The little electrons, as they move through the wires, if they go too fast, if they have a lot of current, so going really fast, if they have lots of current, they'll bump into the metal atoms far more easily. And as they do that, they lose their energy, they transfer it into the metal atoms vibrate more, vibrations leads to heat and things like that. Basically have a huge loss of energy. Lots of other countries get over that by actually sending their energy at higher currents but at lower voltage. So you'll find in France and Spain and Italy they use a lower voltage than we do, whereas we have in America they use 120 volts as well. Yeah, they use they're basically effectively, and no disrespect to those countries, their system is a lot less efficient than ours. Obviously, it works perfectly well, but in theory, it is less efficient than ours. That's why their voltage is lower. So we send ours at a higher voltage because it is more efficient and we lose less heat. And this will take the voltage up to 400,000 volts. Okay, pretty spectacular. That's what the big power stations are, as you can see. So we're on a new bit, the national grid network, the cables and the pylons. So basically the electricity gets transported across the country by these vast pylons. They're safe because they're away from us. You can't get electrocuted from them if you are not grounded. So people often ask, why do the birds not get electrocuted? Well, because the electricity goes through them, but it can't go into the ground, and that's where our sort of problems become when you get electrocuted. Is if the electricity can travel through you, it carries its charge through you and out of you, and that is dangerous. So that's why birds and things don't get electrocuted on the pylons, because they're not grounded into the earth. So that's the pylons there. And we go to a step down transformer that now reduces the voltage down to about 30,000 volts. just so that it gets a sort of reduced it down, because still having 400,000 volts is still dangerous for us. We can't deal with that. It still has a fair amount of current, so we have to reduce it down and reduce it down. So step down transformer, and then to a local substation. Now you guys will have seen these around. They're normally, as you can see in that picture, sort of surrounded by a fence. They'll say danger, high voltage, etc. And that's your local substation. I actually have one down the road from me. And the idea is that it steps it again down and helps distribute out the electricity from that substation into the local area, and that goes to 230 volts for your home. Now, we used to be on 240 volts, and then they realised that actually 230 volts and sometimes even 220 is better. So we used to be at 240 volts, and now we're at about 230, 220. So you may see that in different questions. You may see anything from 240 to 220, okay? So I'll give you time to make sure you've got all those notes, and we've got one more place that the electricity goes to, which is into our house. And as you can see, it comes through the meter. So that's the big interesting thing talking about our bills, is how, when we activate anything electrical in our house, you will see the meter working. Now that's quite an old school meter, but I have lived in houses where they've had a meter like that, and I could tell you now, it's quite funny when you're running a lot of things, you see that meter spinning around like mad. It's quite cool. Lots of meters now are digital and things like that. But the old school meters, you could see them ticking around. Quite funny. So you can see your electricity use in your home through that way. Thinking of our lesson before, right? Assessment for learning, that's what AFL stands for. Why do we need it? Sorry, can't read my own writing. Okay, in your books, I'd like you to write a short paragraph stating why we need to have a national grid. Why doesn't everybody just generate their own electricity? So I'm going to give you a few minutes to do that. I would say spend no more than about 5 minutes. Quick statements. Why do we need national grid? Remember, in science you can bullet point as well if you need to. If you're really struggling, write it down. And then the next thing is, why don't we just generate our own electricity then? Sure, it's perfectly legal to do so. You tell me, why can't we just generate our own electricity? 5 minutes, go, and then come back and we'll be on the next slide. So why do we need it? Well, a national grid is actually cheaper in the long run, cheaper for me and you. Okay, petrol prices fluctuated, things like that on generators, and it works out cheaper in the long run. It's also safer. So that's the last point there. Some of you who'll be listening to this probably use generators a lot because your families use them for all sorts of like camping activities, or you might be showmen and use them on your rides and things like that. And you're probably like, yeah, generators, yeah, they're fine, whatever. But they can be dangerous, okay? Some of you have lived around generators all your life, so you kind of know what's going on, but they can be a little bit dangerous, okay? Also, if they run out of fuel, that's the end of it, right? You've got to keep that thing topped up all the time. So at least, any time you want, you can switch on the electricity. But if you run out of fuel, then what happens if you forgot to get a store of it? You've got to store the fuel. That could be dangerous too. There's lots of laws around all this sort of thing. Yeah, it's not the best idea to have generators into your house. The other thing is they're loud. They hum away like a 16-year-old's moped, or is that 17-year-old? Anyway, those boys that go around with their mopeds, driving everyone up the wall. They do that basically. They're very loud. All right, so basically, not the best idea in the world. But we are starting to get into a place where we are generating our own electricity through things like solar panels on our roofs and things like that. I often tell my classes this. My wife's mother, she lives in the Alps in France, and she generates so much electricity because it's very, very sunny there all the time, which is a problem with Britain because we have a lot of cloud. But she generates so much electricity, she actually sells it back to the electricity company because she doesn't need it. It's fascinating. That's how much electricity she gets from her solar panels. So we can do it that way, which is a good point. Okay, let's move on to the next bit of learning. So we need to just have a think about the step up and step down transformers. Just see if you can remember what they are. So explain what is the need for a step-up, step-down transformer. So can you summarise it? You can write your answer to this question in bullet points. Pause, go tell your family. Okay, you in theory have these notes, but my whole point is, right, you've got all this information, but can you apply it? So when you go tell your parents, okay, go tell somebody in your family, go see if they can understand. You don't have to do this lesson in all, one go. You could pause, you could FaceTime with grandma, granddad, etc. Talk to them and tell them what you've learnt so far, and then come back and do the questions. So have a go and think about that. This does not have an answer because the answers are in the PowerPoint, okay? So go for it, and we will come back and do some high-level questions. Okay, let's get on with those high-level questions. So, first one. What are the advantages and disadvantages of a national grid? Now, you're going to see that I've given you more than 4 points. It's a 4-mark question. You need 2 advantages, 2 disadvantages in this question, okay? It's a 4-mark question. Now, exam technique normally is you spend a mark a minute. It's the first time you've done this. I would probably spend 6 minutes. If you really want to test yourself, if you really want to get yourself prepared for exams, I'd spend no more than 6 minutes on this question thinking about it. If you really, really want to test yourself, don't look at your notes. Okay? Try and see if you can think of what you've learnt so far. If you want to look at your notes, go for it. Alright? But no more than about 6 minutes on this. So pause the video here or the PowerPoint and come back to me in just a minute or 6 minutes. So, the advantages and the disadvantages. So advantages, it is transferred more efficiently across the country. We've said that. We help reduce energy loss through heat. It takes up less space. Okay. If there is a problem in one area, more energy can be diverted from another area. Disadvantages. Power stations are unsightly, and power cables and pylons and things, they are unsightly and take up space. Another little factoid for you. Again, when I go and visit my in-laws in France, I certainly have that feeling. They've got these beautiful mountains, absolutely stunning mountains, and then you see all these cables across everywhere. You think to yourself, "Oh man, it just kind of spoils it a little bit." But I get it. The people live in the villages there. They need electricity. I'm not an idiot, but just kind of spoils it a little bit. It'd be kind of nice if they didn't have all these cables and things. So they're just not nice. Also, you need a lot of infrastructure. So we were, and hopefully are still, a successful developed country. Okay, we decided to produce electricity this way and get electricity to everybody in our country. Other countries are still developing and they don't have the money to put the infrastructure in to get electricity to every home in the country. Okay, so it does cost a lot to do so, and it's countries that are doing incredibly well and have a bit of extra money to spend around on doing these things will do that. So Britain will, a case of doing that. Or you could, this bit of business studies, you could think of that it might cost money. It might mean that you have to borrow money from somewhere like the International Monetary Fund or the World Bank or something like that, but in the long run, it will make your country better, and you'll make more money and pay that off, and then have lots of money. So it's kind of swings and roundabouts when it comes to this little bit of business studies there for you. Okay, next question. The diagram shows the national grid system. This is directly taken from a past question, by the way. The national grid includes step-up transformers. Explain why. 2-mark question on step-up transformers, and give yourself 2 to 3 minutes on this. Why do we have a step-up transformer? Go for it. Well, hopefully you have said that it increases the voltage and reduces the energy loss, okay? Or you could have said reduces the loss of energy by heat, or increases the efficiency. So we've talked about this a lot. So really, really well done there, ladies and gents. It's a very cool topic. I personally really like this topic. Tricky one to sort of get your head around, but once you get your head in, you smash it, okay? So I've got a new question for you. Plenary question. Overhead or underground power cables? What are the benefits? Why aren't we putting power cables in the ground? Why do we do them overhead? So I don't have an answer for that for you. I mean, I do have an answer. I know exactly what I would say. But see what you think, okay? What do you think are the benefits? What are the drawbacks of both systems? Putting electrical cables in the ground or putting electric cables over the in pylons. And when you've done all this, if you want to test yourself, go on to Show My Homework, and you'll see I've set you a quiz all about this. Test your understanding, and then I get some data and see what you guys are doing, and have a go. Remember, any questions, any problems, you let me know, and I will happily answer them. Take care, ladies and gents. Bye.